There's a white powder that costs $1 at any grocery store in the world. $1. You probably have it in your kitchen right now. You've baked with it. You might have used it to absorb odors in the fridge. But when you put this powder in your oven for 1 hour, it turns into something completely different. Something that strips grease from fabric, softens hard water, lifts out sweat and mud and food stains, and cleans your clothes better than most name-brand detergents, at less than a penny per load. No synthetic dyes, no petroleum-based surfactants. Those are the chemicals that make detergent foam, like soap bubbles made in a lab. No plastic jug that runs out every 2 weeks, no subscription. The global laundry detergent industry was worth $96 billion in 2022, according to Grandview Research. That is not a number built on superior cleaning science. That is a number built on the fact that most people never learned what you're about to learn. You cannot build a $70 billion industry on a $1 box, and that is exactly why nobody told you. There is one thing that can go wrong with this process, and it's invisible, and it happens before most people put a single piece of clothing in the machine. We are going to get there. But first, you need to understand why this works at all. The laundry detergent industry, worth $96 billion annually, according to Grandview Research, runs on one mechanism. You run out and you buy more. Procter & Gamble introduced synthetic laundry detergent to American homes in 1946 with the launch of Tide, spending tens of millions of dollars in advertising to replace a method that had been working since long before written history existed. A process that costs $1 and produces a year's worth of cleaning powder cannot be bottled, labeled, or delivered on a subscription. That silence is not an accident. That silence is a business model. Now, let's go back further. Ancient Egypt, around 3100 BCE. Archaeologists have found records of it in administrative papyrus from the Nile Delta. The Egyptians had something they called natron. It formed naturally when shallow lakes in the desert dried out, a white crust left behind on the lake bed, like salt left on your skin after a swim in the ocean. They collected it, stored it, and traded it like currency. They used it to wash clothes, clean skin, preserve food, and prepare the dead for burial. Natron is sodium carbonate. It is the exact same compound that comes out of your oven when you bake a box of baking soda for 1 hour. Same mineral, same chemistry, same result on dirt and grease. The only difference is that the Egyptians dug it out of a dry lake bed and you're going to make it on your kitchen rack. The Romans had the same chemistry without the desert. They used wood ash. When you burn wood, the ash left behind is rich in potassium carbonate, the same family of compound, alkaline like the natron, working the same way on oil and stain. Roman commercial laundries, they were called philonicae, which is just the Latin word for the place where wool was cleaned, were built entirely on this method. The Roman architect Vitruvius described the process in writing around 15 BCE. The Roman army kept hundreds of thousands of soldiers in clean uniforms across Africa and Europe and the Middle East using ash, water, and time. No factory, no supply chain, just the chemistry of burned wood doing what alkaline compounds do to dirt. Medieval Europe never lost this. Soap makers across England, France, and the German territories ran water through barrels of wood ash to produce lye, a concentrated alkaline liquid, and then mixed that lye with animal fat to make bar soap. That was the cleaning technology of the world for over 1,000 years. It was not considered primitive. It was considered effective, because it was. You have encountered this chemistry without knowing it. Think about the last time you tried to clean a greasy pan with just cold water. The water rolled off the surface, nothing moved, nothing let go. Then you added dish soap, and the grease broke free almost immediately. What happened in that second moment is what this powder does to fabric at the level of individual fibers. It breaks the grip. Grease and oils bond to cloth the same way grease bonds to a pan. An alkaline compound, something on the opposite end of the chemistry scale from an acid, the way baking soda is the opposite of vinegar, slips between those bonds and releases them. Water carries everything away. That is the whole process. Think about the white scale inside your kettle. That is mineral buildup from hard water. Calcium and magnesium that were dissolved in the water and got left behind when the water boiled off. Washing soda binds to those same minerals in your wash water and pulls them out of the equation before the water even touches your clothes. Soft water, water without those minerals, cleans significantly better than hard water. Your clothes come out cleaner not just because the powder is directly cleaning them, but because it has improved the water itself first. You have seen this your whole life, you just never knew what you were seeing. The mistake most people make with this process doesn't happen when they put the powder in the machine. It happens in the oven in the first 10 minutes, and because the powder looks exactly the same before and after, most people pull it out too early and never know it didn't work until the first load comes out wrong. Here is what you need. I want to be honest with you about every number. Baking soda, 1 pound. You can buy a standard 1 pound box at any dollar store, grocery store, or pharmacy for $1 or less. If you want to start with more, a 5-pound bag at a wholesale store like Costco or Sam's Club runs about $3 to $4 and will give you enough finished powder for over 50 loads of laundry. Start with 1 pound to learn the process, a baking sheet or oven-safe glass dish, anything flat that you already own and use for cooking, a glass jar or airtight container for storage. A standard wide-mouth mason jar works perfectly. So does any container with a lid that seals, optional but useful. 1 bar of plain hard soap. Castile soap, Fels naphtha, or any bar soap that contains no lotion, no conditioner, no moisturizer. Look at the ingredient list on the back of the bar. If it says anything about aloe or shea butter or skin softener, skip it. You want soap and nothing else. 1 bar costs about $1 to $2 at most grocery stores. Optional, a cheese grater if you're using the bar soap. That is genuinely it. You start with the oven, set it to 400 degrees Fahrenheit. That is the same temperature you would use to bake a frozen pizza. While it preheats, spread your baking soda across the baking sheet. You want the layer to be about as thick as a pencil, thin enough that every bit of the powder gets even heat all the way through. If you pile it up in the middle, the powder at the bottom won't convert properly. Use a spoon or your finger to spread it flat all the way to the edges. Put it in the oven, set a timer for 1 hour. Not 45 minutes, not 50, 1 hour. Here's the one thing most people get wrong. The powder looks completely identical before and after the conversion. It starts white. It stays white. It doesn't change color, doesn't smell different, doesn't bubble or shift. Most people open the oven at 30 minutes, see that nothing looks like it has happened, and assume something is wrong, so they pull it out, and nothing has converted. Because what is happening inside that powder is completely invisible. Baking soda is sodium bicarbonate. Think of it like a crystal that has a tiny bubble of water and a tiny bubble of gas locked inside its structure, the way a piece of ice holds water solid. When heat reaches that crystal, it breaks the structure open. The water becomes steam and rises away. The gas, carbon dioxide, the same gas in carbonated drinks, releases upward and vanishes. What is left behind is a different crystal entirely. Sodium carbonate. The structure is harder, the mineral is denser, and critically, it now holds onto grease and mineral deposits instead of releasing them. But you cannot see any of this from outside. The powder stays white and looks unchanged. That is why the timer matters more than your eyes. Do not trust what you see, trust the clock, full hour, every time. After the hour is up, take the baking sheet out and set it on the stovetop or counter to cool. This part matters. Hot powder moved into a sealed jar creates steam. Steam in a sealed jar creates moisture. Moisture turns your washing soda into hard clumps that won't dissolve well in the wash. Wait until the pan feels cool to the touch, roughly as long as it takes to make and eat a full meal, before transferring anything to the storage jar. Once the powder is fully cool, transfer it into your airtight container. Label it clearly. Washing soda and baking soda look nearly identical in a jar, and you do not want to accidentally use baking soda in your wash or washing soda in your cooking. If you're adding bar soap, do it now. Take the bar and run it across the smallest holes on a cheese grater, the same side you'd use for hard Parmesan. You want fine flakes, almost like powder. Coarse chunks won't dissolve fully in a washing machine, especially in cold water, and they can leave small white spots on dark fabric. Fine flakes dissolve fast and completely. Add the soap flakes to the jar with the washing soda. For ratio, imagine filling the jar 2/3 full with the powder and then bringing it up to the top with the soap flakes. Shake or stir everything together. For a normal load of laundry, use 2 tablespoons of the mixture. That is about the amount a standard coffee measuring scoop holds. For a heavy load, work clothes, muddy jeans, sports gear, anything that genuinely smells, use 3 tablespoons and add half a cup of plain white vinegar to the fabric softener compartment of your machine. The vinegar does 2 things. It neutralizes any alkaline residue that might be left in the fabric after the wash cycle, which matters for people with sensitive skin, and it acts as a natural fabric softener. A gallon of white vinegar costs less than $2 at any grocery store and lasts most households an entire year of laundry. Add the powder directly to the drum of your washing machine before the clothes go in, not the detergent drawer, the drum. This puts the powder in direct contact with the fabric from the very first second of water entry. It dissolves faster and more evenly this way. If you have a front-loading machine, the kind where the door is on the front and the drum is horizontal, dissolve your 2 tablespoons in a cup of warm water first, then pour the liquid into the drum before adding clothes. Front loaders use much less water than top loaders. If the powder is not pre-dissolved, it may not fully mix in time. An undissolved powder on dark fabric leaves a faint white haze that is difficult to rinse out completely. The warm water step takes 30 seconds and eliminates that issue entirely. For water temperature, warm or hot water activates the powder faster and works better on oil-based stains, food, and sweat. Cold water works for lightly soiled everyday clothes, but needs a head start. Dissolve the powder in a cup of warm water before adding it to a cold wash, regardless of what type of machine you have. Your first load should be something expendable. Old towels, a worn set of sheets, work clothes that are already broken in. This is not because the process is risky, it is because every household has different water. Some tap water is harder than others, more minerals dissolved in it, and harder water needs slightly more powder per load. Softer water needs slightly less. One test load gives you that information out before you wash anything you care about. The test to know if a load worked is simple. Pull a damp item out of the machine immediately after the cycle ends and hold it to your nose. Washing soda leaves no smell at all, no fragrance, no soapy scent, no chemical note. If the item smells clean and like nothing, the powder worked. If it still carries any odor from before the wash, add half a tablespoon more next load. Your nose tells you everything. No measuring device needed. 1 pound of baking soda at $1 converts to roughly 22 to 24 loads of laundry at the standard 2 tablespoon dose. According to the American Cleaning Institute, the average American household runs about 300 loads of laundry every year. That means one household needs roughly 12 to 14 pounds of baking soda annually to replace commercial detergent entirely. At dollar store prices, that is $12 to $14 for a full year. The American Cleaning Institute's own consumer data shows that the average American household currently spends between $150 and $200 per year on laundry detergent. The difference between 14 mice and 175 is not a difference in how clean your clothes come out. It is the cost of the plastic jug, the branded fragrance, the television advertisement, and the shelf space in the store. A family of 4 running more laundry through this machine steps up to those 5-pound bags at a wholesale store. 2 bags at $3.50 each converts into more than 200 loads of laundry. Enough for a full active year for most families, at a total spend of $7. $7 for a year of clean clothes. For someone thinking further ahead, a homestead, an off-grid property, a family that wants to stop thinking about this entirely, baking soda is available in 50-pound bags through restaurant supply stores and food-grade chemical suppliers for around $25 to $30. One 50-pound bag converts into more washing powder than most households use in a decade. It stores indefinitely in a sealed, food-safe container. It does not expire. It does not degrade. It does not attract insects or rodents. It sits on a shelf and waits. No delivery schedule. No subscription. No dependency on any supply chain, any shipping service, or any store being open. No bills. No infrastructure. No asking anyone's permission. There is one more thing about this that took a long time to surface, and it changes how you think about the entire problem. This powder is safe for septic systems. Standard laundry detergent contains surfactants and phosphates that can disrupt the bacterial balance of a septic tank over time, according to the University of Minnesota Extension. Washing soda contains no synthetic chemicals. It rinses fully out of fabric. It breaks down in water with no harmful residue. For anyone on a septic system, a well, or any private water system, this is not a minor point. It means the water flowing out of your laundry and into your soil or your tank is not carrying a chemical load. The Egyptians were not polluting the Nile with their natron, neither are you. There are a few real limits worth knowing honestly. Washing soda handles most everyday soil well: sweat, food, mud, general grime accumulated from a normal life. For protein-based stains, things like blood or raw egg or fresh milk, cold water works better than hot. Heat sets protein into fabric the way heat sets an egg in a pan. Use cold water for those stains and treat them as quickly as possible after they happen. For oil-based stains that have soaked in deep, engine grease, heavy cooking oil, put a small amount of ordinary dish soap directly on the dry fabric before washing. Rub it gently with a finger. Let it sit for 5 minutes. Then wash normally. This is not a weakness of the powder. This is how stain chemistry works, regardless of what you are washing with. Commercial detergent handles some of this automatically because it contains several different cleaning agents blended into one product. This powder is one agent, a very powerful agent, but for those specific stains, a small amount of dish soap as a pre-treatment gives you the same result. 1 bottle of dish soap, used only for pre-treatment and not for full loads, lasts most households an entire year. The Egyptians who bent over the Nile and scrubbed their cloth with natron 3,000 years ago did not have brand loyalty. They had chemistry, they understood what made dirt let go of fiber, and they used it without ceremony and without a corporation telling them what the product was worth. That knowledge did not disappear. It was not improved upon in any meaningful way by what came after. It was replaced by something that could be sold, packaged, and advertised. And then the older knowledge was buried not under evidence of failure, but under the quiet financial logic of not promoting what you cannot charge for. The powder in your oven right now is the same compound those workers used. Different name on the box you bought it in. Same mineral structure, same behavior in water, same result on a stained shirt. 1 hour of heat, $1 of material. One habit that removes a recurring cost from your household permanently. Not until the next product comes out, not until the formula changes, but permanently, for as long as you can heat an oven and open a jar. That is not a trick. That is not a shortcut. That is what self-sufficiency actually looks like in practice. Not a dramatic gesture, not a survival fantasy, just the knowledge that your great-grandmother's great-grandmother used, recovered from a dry lake bed in the desert in a pile of ash by a Roman fire, and handed back to you in a single afternoon. Start with one box.